Subscription that you can develop the question. See, so what we have what the numbers and arts get what got it's you and there's you about it with the pocket. They're not doing it. So, it's amazing what she's doing. This thing, you say you don't. Well, I particularly it's made discovery of finite days of value used almost impossible. Yes, a family universe. Yes, but then complete background for data, not other technical, but even usually plan can keep up to once, आप शुरू में भी दाल हुआ ये अब मुझे नहीं मैंने मेरे को ऐड किया है तो सब कुछ मैं देख रहा कि हम बहुत सॉफ्टवेयर में जाऊंगा किसी भी बात आपने जॉब ऑफर ले नहीं हुआ I decided to not do anything. बड़ों में जिसको कोई दिक्कत नहीं अटेंड का पर इसमें बहुत सारा इम्पैक्ट कर जाएगा मैं तो बता वीकेंड मैंने ध्यान नहीं था जब मैं रीचिंग सैटरडे इवनिंग एक सैटरडे के लिए जाऊँ कि वापस आ बस से एक्चुअली वेरी अपसेट बस 125 kilometers मैं जो पे सारा स्ट्रेस can do online. Allora, it's not one.
So, good morning, all of you. Today with us we have an eminent personality from University of Allahabad, Dr. Arup Acharji, and he's a real expert when it comes to real-time PCR and next-generation sequencing. So, we are welcoming Dr. Arup Acharji, and Dr. Arup Acharji is saying that he will introduce himself by himself only. So, Dr. Arup, please. And personally, Dr. Arup is a very good friend of mine. He's like a younger brother to me. And I know him since the MSc days, even before that,
2006.
2006 rather. So it's a long time association of more than almost, it's going to be 2 decades. Okay. So, Doctor, please.
Hi. Good morning to all of you. First of all, I will like now to redact the eminent word. So, still miles to go to become eminent. But yes, I did a lot of my RT-PCR studies during my PhD. Now I don't do much of RT-PCR. So, might be my knowledge is a bit old by about 4 5 years. But the basics have remained constant since 2008 and 9. So we have achieved that plateau phase, which we will discuss very soon. So information, few technologies have moved up, few innovations have come up, but primarily even if you do RT-PCR or qRT-PCR today, it will be of the same use. I was also very lucky because I could use my knowledge for public benefit and public good. Uh, Back in 2020, when there was the COVID pandemic, WHO had sent out a call for volunteers, and you would be amazed to know there were only two volunteers from WHO, which boasts of about 2,000 faculties and research scholars from life sciences and allied streams. So that's a reality of life when people will ask for help. Most of you won't be ready for help, but please do it, not for your own benefit. When I walked into that COVID diagnostics lab, I was very sure that I might die the next day because that was the very first phase of the pandemic. Everybody was trying to keep at least 2 to 3 kilometers distance from a COVID patient. I was there handling VTMs, or viral transport media, and most of them were positive. And we were doing it for the entire of eastern Uttar Pradesh. So you had Prayagraj, Balia, apart from Varanasi, so almost 20 to 25 districts were doing that. And what I learned during that phase is there is a great joy in philanthropy. Today, I'm really proud to say that I know real-time PCR and know it effing good. Anyway, so we will discuss the basics first, and then we will try to give. I've got 1 hour from CP sir. 1 hour is not enough, so I will brush you through the basics, take down the notes, maybe the keywords, and then do read up more from Google, from PubMed, from ChatGPT, whatever be your source. Okay, so when we use the word real time, think of how many of you have shared location on WhatsApp when you are traveling alone, especially girls? Many of you have done that, right? You know, when I used to travel back from my village back in the 1990s, even if I was to travel alone, the only way of telling my parents that I'm home or I'm back to my place that I'm supposed to be, even when I was studying my master's, was a telephone call at the end of the journey, right? Because I did not have a mobile phone. So you get down from the bus or rail carriage, rush to an STD ISDP booth. Many of you might not have seen it. Try to watch few old movies. You will see there's a big box, STD ISD PCO, public calling office. So you will rush to a PCO and tell that, okay, I'm where पहुंच गया, the hostel पहुंच गया, या बनारस पहुंच गया, whatever be there. So what I was doing was I was giving an endpoint information throughout the journey. ट्रेन लेट हो गया, ट्रेन बहुत जल्दी चली, बस का टायर पंचर हो गया. Nobody knew about it. Now you share a real-time update with your father or mother. She will click on the map and then she will try to see क्या हुआ, एक ही लोकेशन पे तो बहुत देर तक खड़ी है, सब ठीक है ना, right? I think all of you. So this is what we do with real time. We want to know information about gene amplification in the real time. So today's lecture would be how we do that. What are the technologies at hand so that we know, and what are the advantages. So if you go back to the book definition, it's a specialized technique that allows a PCR reaction to be visualized in real time. So if you look at this curve, you see there are multiple curves, and you would see all these curves would have a typical shape. We have successfully destroyed. So we would see this exponential shape, right? Somewhere there is this lag phase, then there is a linear phase, and then we reach a plateau. Complete why we reach a plateau. But this is the basic shape that you would find for any qPCR. And what we do and what are the difference. So if you start with a normal PCR, how many of you have done a normal PCR? Like many of you? How many of you have not done any kind of PCR? PCR के बारे में सुना ही नहीं. It's perfectly fine. That's why you're in the workshop. जानने के लिए तो आए हो. जान के आते तो workshop में क्यों आए? So what is PCR? It's a polymerase chain reaction. Basically, it's an enzyme catalyzed reaction. And what is the enzyme? Enzyme is a DNA polymerase, specifically Taq polymerase. Why Taq polymerase? Because any DNA polymerase we have done, but Taq polymerase is carboxyl. And we do it in vitro replication of DNA. So there are basic temperature cycles like 94 is called the denaturation cycle, right? We denature basics of kinetics of DNA. If you heat DNA, the hydrogen bonding breaks up and you get single-stranded DNA. So what helicase and topoisomerase does in vivo DNA replication and single-stranded binding proteins, if you remember DNA replication, heat is doing it for you here. It is allowing the DNA to remain single-stranded. Then you bring it at 61 degrees Celsius. This is special. So what is 61 degree? This is an annealing. Annealing, who anneals? Primer anneals. And why do we need a primer? And again, if we go back to the root cause, because DNA polymerase cannot start without a primer, so it would need a primer. That 3' OH is required. And then you allow it to work at 72 degrees Celsius. They say this is an enzyme catalyzed reaction, so it would need temperature at which it can work best. For Thermus aquaticus polymerase, it's 72 degrees Celsius. If I suppose to do it with human, no, I can't do it with human in vitro, but in vivo, everything is happening right now in your body at 37. And why do we do it? So first of all, we do it for gene expression analysis. Why do we need to know gene expression? Karna kyun hai? Because whenever we do some intervention, suppose you are trying to develop a new drug, and you are telling that this drug of mine can reduce oxidative stress, right? Or it can cure cancer. So we would mostly have some biomarker or pathway genes. And one good way of estimating whether your drug is working or not is how they are affecting the gene expression. Okay, so real-time PCR gives a very good way of estimating or understanding that gene expression pattern. Then disease diagnosis. I think all of you, somebody would have poked a long swab in your mouth. You would have hurt a bit during COVID days. What we were doing was we were trying to get the upper respiratory tract swab so that we can check for viral DNA. So it helps in disease diagnosis, not only in viral, it can do the same for cancer, it can do the same for bacterial. Basically, even if there is a small genomic material, it will likely amplify because these are amplification based techniques. I'm not getting into the very basics of PCR, but you would know that PCR is amplification based, right? You are amplifying with each cycle of PCR. You are going for an exponential amplification. Food testing, especially in the first world countries where they have abundant food, they can go for food testing, whether there is a genetically modified fragment of DNA in that food and stuff like that. Transgenic research can be in research. We want to understand the gene copy number. So we have lots of applications and real-time PCR is very good. So, one question that arises is if Taq polymerase does replication of DNA, how can we study gene expression or how do we assay for gene expression? Because basically, Taq polymerase will synthesize DNA, right? So what? How can you use it for understanding and expression of a gene? So there are two methods, but before going into the methods, I would like to say that there are multiple ways of doing it. So what I'm trying to tell you here is a two-step PCR. Next, at the very end, we will discuss what is one step and two step. So this is a two-step RT-PCR where first you take mRNA, right? This mRNA is the total mRNA from the cell. And once you take the mRNA, there is no way you can use Taq polymerase to amplify the mRNA. What you need is reverse transcriptase, right? So you take multiple, there are lots of reverse transcriptase available in the market. There are multiple vendors. They will sell you reverse transcriptase. To take reverse transcriptase, you can take specific primers. Usually we use oligo DT or random hexamers, and then you prepare something known as the complementary DNA, cDNA. Now, once it is complementary DNA, now it has become DNA. Now, Taq polymerase can act on it. So, first of all, it was use reverse transcriptase, convert the mRNA to cDNA, and then use this cDNA as the template to amplify. Now, just before we were doing real-time PCR, even yesterday when we were talking with Rajkumar, he taught me a lot of this. We used to do it by agarose gels. And the word we used for agarose gel was semi-quantitative PCR. This is quantitative qPCR. Quantitative, okay. Prior to that, we used agarose gels and we called it semi-quantitative PCR. Okay. And what we did was, we amplified our gene of interest. Now, there was two kinds of answers that it used to give. First, a yes and no answer, right? A binary answer. Is the gene expression happening? Yes or no? So here we are not telling whether how much of the gene is overexpressed or if there is any under expression. यहाँ पे सिर्फ ये सवाल है, if that particular person was present in that room, yes, then you will have a band. If that person was absent, you won't have a band. As simple as that. That is also a kind of assaying for gene expression. Suppose you want to do for viral diagnosis. You want to check for a pathogen. There, a yes no answer is good enough. You don't need to see a curve, right? Much of the science was happy doing that. Then you had the semi-quantitative part where you needed to plot with each cycle how much of my band intensity is increasing, right? So this was again a semi-quantitative plot. So you have used to stop the PCR run at 10, 15, 20, 25, 30, 35 cycles. And then you used to plot. And that would give you, at one phase, you would see that you have reached the plateau. Maybe from 30 to 35, there was no increase in your band intensity. You can stop me if you have to find any step confusing. So, I think by using a permanent marker. So what I'm trying to say is, suppose you have 5 tubes, and each tube you put your master mix, and you run this for 10, 15, 20, 25, 30, and maybe one more for 25. You run these for these many cycles using your forward reverse timers, like a semi-quantitative. And then you get bands. Somebody was to do a very, and then there are softwares for density-based softwares. So what can we assume from here? That from 30 to 35, there was a very negligible increase in the signal. That means the reaction has reached this plateau phase. So again, so what we used to do at back then was we would design our assay in such a way that we would not run beyond 20 cycles, or we would actually run 25 cycles, because now here you see there is a linear increase in the amount of DNA. But still there were multiple